Chapter 9, Lesson 6 and 7, Properties of Logarithms and Solving Logs. Okay, go ahead and pause here and write down these properties of logarithms. The first one we have here is the product property of logarithms, which says that if I have two numbers that are multiplied, which is what product means, and they have the same log, base b, I can actually expand them to be two separate logs added together. So it kind of goes back to when we had even just our simple x to the second times x to the fifth. I would add those, 2 plus 5 to be x to the seventh. So we're kind of still, logs and exponents are opposites of each other. So we're still kind of in that same mind frame. So for the quotient, which quotient means divide, then I would subtract the two numbers. So same thing if I had x to the fifth over x to the second, I would take 5 minus 2 to be x to the third. And the last one says if you have a power on your number there, you can put that multiplied out front of your log, and that would be the expanded form. So for examples of the product property here, it says write each sum as a single logarithm. So these two I would take and make log base 11 of 30. The next one I have log base 3, and then half of 12 is 6. The next one's going to be a distribute here. So I'm going to have log base 2 of x squared plus 2x. And I'm going to put that in parentheses so you know that it's a single logarithm. The next we're talking about the quotient property. So remember that is subtraction with division. So this one would be log base 10. 27 divided by 3 is 9. This one, log base 5 of 8 over x. Not like terms, so I can't simplify, so I just leave it like that. Same case here, log base 3 of x squared plus 5 divided by x squared plus 3. Neither the x squared plus 5 nor the x squared plus 3 can be factored, so I don't have to worry about reducing any of that. For the power property, the exponent becomes the coefficient out front, so this would become 3 log base x of x. This one is showing square root, which remember that square root is the same thing as the 1/2 power. So this one would become half times log base 4 of x. This one we're talking about combining these two things. So the first thing I want to do is change these coefficients into my exponents on my numbers here. So this would become log base 5 of 3 to the second plus log base 5 of 2 to the third. Then I would want to combine those with multiplication. So I have it's going to become 3 to the second times 2 to the third. 3 to the second is 9. 2 to the third is 8. So my final answer is log base 5 of 72. My next one, same thing. I want to change these into my exponents. I guess I only have the 3. So first step would become log base 9 of x to the third minus log base 9 of x plus 1. And then subtraction means the quotient rule. So final answer would be log base 9 of x to the third divided by x plus 1. For the last one I check out front, there are no exponents. So the first one is an addition. So I'm going to have log base 4 of 25 times 3. And then I have a subtraction. So then that would be divided by 5. So 25 times 3 is 75. Divided by 5 is 15. So my final answer is log base 4 of 15. Okay, for lesson 9-7, we're going to be solving log equations with no shown base. So when there is no shown base, the base is 10. So in these ones, if I'm looking for solving these, I can use my calculator whenever I have a log base 10, because that's the basic function in the calculator. So for this first one, I have log of 10, log base 10 of 10. And so I can put it into my calculator if I can find my TI. There we go. Okay, so the log key is to the left of the 7 key. And I have log, and again, if there's no base, it's showing log base 10. And so when I type in log base 10 of 10, I get 1. The next one is log base 10 of 1,000. So just type in log of 1,000, which is 3. And I continue, so I have log of 1/10 is -1. Log of 6.78 and log of 8.46, 0.93. So that was when we had log base 10 of 10 equals what? Now we're going to be changing and putting x in the spot here. And again, if there is no base, it's 10. So this one I could actually rewrite as log base 10 of x equals 3.1. Now, to change this to exponential form, which we did in previous lessons, this would become 10 to the 3.1 power equals x. So now I could just type it in as 10 to the 3.1, just like this. And that's how I get 1258.93. 1258.93. So again, this would be log base 10. So we change that into 10 to the 2.7 equals 4x. 10 to the 2.7 is 501.19 equals 4x. Divide by 4. X is 125.3. Put my base 10 in here. So I have 10 to the 4th equals x plus 2. 10 to the 4th is 10,000 equals x plus 2. Subtract 2, subtract 2. X is 9998. Next one, again, this would be 10. So 10 to the 7th equals 3x minus 1. 10 to the 7th, 1,000,000,000 equals 3x plus 1, or minus 1, sorry. So I'm going to add 1 and divide by 3. So x is 3333.9. 67.